Okay, this is really 8.4, May 31st. Text page 428, Blue Notebook page 514. We're going to do question number 5, straight out of your homework. Okay, it tells you the Earth's distance from the Sun. So, we have Earth, Sun, and also in the question we have Mars. Okay? Now, this question tells us that Earth to Sun, we'll say to there, is the equivalent of 149,600,000 kilometers, which is also known as 1 AU, astronomical unit. Okay? So call this 1 AU. It also tells us that at a certain point in time, Mars is 1.5 AU from the Sun. So, Earth is 1.5 AUs from the Sun. And one evening, Mars is seen from Earth to make an angle of 68 degrees with the Sun. So we complete our triangle. And now what's up about this question is, where do I put my angle? It says it makes an angle of 68 with the Sun. So what we're assuming is from Earth we're looking at both Sun and Mars. So that means the angle it's making here is 68 degrees. Okay? Now, what I'm going to do in this question is I'm going to change something. I'm going to change the question around just a little, and I want Earth to be 1.5 AUs from Mars. Okay? And the reason I'm doing this is because we're going to do cosine and sine law in this question. So I'm just going to change it to that for this specific question. Now when I look at this, if I were to name this triangle, if you guys remember, I'm going to call this angle A, so this is side A, angle B, side B, and angle C, side C. If I take a look at that, if I use sine law, I don't have an opposite side and angle for any of these. So I can't use sine law to solve this. I need to use cosine law. And what I'm going to do is I'm going to solve for the distance between Mars and the Sun. So, cosine law is c squared equals a squared plus b squared minus 2ab cos c. Now our cos c is 68, and we're trying to find the distance between Mars and the Sun. So that leaves me with c squared is equal to, the only thing is when I name this triangle, I call this ABC. I'm going to actually have to rename it, because remember, we want our C to be what we're looking for. So I'm going to change that. This will be A and A. This will be angle C and side C. Okay? So our A is 1 AU. We're going to measure in astronomical units. Our B is 1.5 minus 2 times 1 times 1.5 cos of 68. C squared is equal to 1 plus 1.5 squared gives us 2.25. Subtract the by. I'm going to do this all in one step. 2 times, I only need to do 1.5 because no matter what I multiply by 1, I'm going to get the same. 3 cos 68. I'm going to add 1 plus 1.25, which will give me 3.25. Subtracted by 3 times cos 38, or 68. So remember, I need to do cos 68 times 3, which gives me 1.123, we'll say. So I'm going to subtract from that answer 3.25 subtracted by my answer above. I'm going to take the actual answer from above just so I'm very accurate. C squared is equal to 2.126. And I need to square root both sides in order to solve for just my C. So I square root this side, square root this side. C will equal, and I'm going to take the square root of the answer above again, 1.145, approximately, okay? We know it goes on from there. So approximately 1.145. So what I've just discovered is the distance from my new measurements from the Mars to the Sun is 1.45. Which if we were to actually be in space, is this true or false? Anyone know? Why is it false? Why could it be true? Which is closer, Mars or Earth to the Sun? Ah, good. So this could be true. It says Earth is 1 AU, Mars is 1.45. That makes sense. Yeah. Can you get out of the way? Okay, and finally, let's say you are a Martian. A Martian is someone who lives on Mars, by the way. Okay? So, if you're a Martian, I need to find out at this exact same point in time, if I'm looking at Earth and Sun, I want to know the angle that Earth and Sun are making from Mars. So I could use cosine law again, but because I have all sides of the triangle now, I do have an opposite ratio. My C's are opposite, which means I can use sine law. Sine law is a little easier to solve. So my sine A over A equals sine B over B equals sine C over C. And I think I put the capitals in lowercase backwards there, but hopefully you have the idea here. Our sine C is 68, and our side C is 145. So I have sine of 68 divided by 1.45. And I want to know the angle of Mars, which we called A. So I'm going to set it up with sine A, which is what we're looking for. I'm going to change it to the proper thing. And our side A was 1. Remember, I can drop the B ratio because I'm not solving anything in it, so I just put those two beside each other. So I cross multiply 1.45. Oh, you know what? I don't even need to cross multiply. This is a very easy question. What is sine A divided by 1? Sine A. Sine A is equal to sine 68 over 1.45. We're going to equate that. So sine 68 equals divided by 1.45. We get sine A is 0.639. And remember, to solve for A, when I bring sine over, it becomes inverted. So I take second function sine of the answer from above. And angle A is 39.7, which we're going to round to 40 degrees. So if I was a Martian, at that same point in time, Earth and Sun will be making an angle of 40 degrees. And finally, say you are Phoenix, and you live on the Sun. What is the fastest way to figure out? Yes, it exists. Yes, the fastest way to do this is subtract our two angles from 180 for the last one. So 180 subtracted by 68 subtracted by 40. 140 subtract 68, 72. So the largest angle there would be at Sun, 72 degrees.